let's talk a little more about what we mean by prediction in our prediction model. So going back to it, this example, you've seen this before. Y hat equals 65.7125 plus 0.3534 times X, or traffic equals 65.7125 plus 0.3534 times the advertising expenditure. The model, quote, predicts that for every $1 spent on advertising, 0.35 more people will enter the store, and that for every $10 spent on advertising, 3.5 more people will enter the store. So, what will the actual increase in traffic be if advertising is increased by $10? Well, let's put this. The thing with our prediction model is that the model can only describe what happened in the past. So this is really important. I should have started with that. This is something really important to remember about any prediction model. It can't predict what will happen in the future. So based on past data, we can estimate that when we increase advertising dollars by $10, that we will have 3.5 more people. But will that actually happen in the future? Well, we don't know. We can estimate, right? So there's that whole concept. And then here's another important concept is the relevant range of a regression model. So I asked about $10, you could do 100, but what about $10,000? What does the model predict store traffic would be if advertising is increased $10,000? Well, according to our model, if we would plug in that information, that would be 3,534 people, or around 505 people for every hour the store is open. And so would you say that's realistic? No, not really, because these are no, because these are little yarn shops. They're not going to get that kind of traffic just by advertising $10,000. And besides, $10,000 is a lot of money for advertising for a small yarn shop, right? So that's just not going to make sense. So as I mentioned before, regression models allow us to make estimates, but this ability is limited by the range of our independent variable. And in our prediction model's case, the data that we used, it ranged from $0 in advertising up to 342. So it would not be useful for $10,000 because $10,000 is not within the range of our sample. A prediction model is useful only within the relevant range of the independent variable. So, okay, 10,000 was unrealistic. What about 500? Well, no, that wouldn't work either because, again, it only goes up to $342, our sample. So we have no information about what happens when advertising exceeds $342. We don't know if the regression line would keep going up, as is the case for A, like maybe it'll keep going like that, right? So let's put that here. Or maybe it'll flatten out like it does here. Like maybe it goes up to a point and then maybe it starts doing that. We just don't have the data to make that kind of call. And so to summarize, things to remember about the prediction model. It's actually a description model. It describes what's happened in the past. It cannot predict the future. And then all regression models have a relevant range. This range is limited to the range of values on your independent variables. So like in our example, we can't go past $342 because that's as high as it goes in our sample. And then also beware of reverse causation and spurious correlation. So take a look at, if you need review, take a look back at our correlation playlist of videos. All right, in the next video, let's do another example.